Hello, everybody. My name is Ian Cookson. I hope everyone can hear me well enough. As you can tell by the slide, I'm the product manager for Oracle Clusterware, which you're all very familiar with, I'm sure, and then application continuity, which is the subject of interest today. The subtitle here is kind of significant because it's running applications without interruptions. Okay, and we'll get more into that in a moment. The focus here is primarily on the continuity of applications and application workloads. Okay, so application continuity and hiding interruptions. This is part of the MAA series, and so this rightly fits there. It builds on top of what the MAA architectural blueprints provide for you. So as you deploy your data structures and databases and database infrastructure, following these best practices, the intent is to provide HA, or high availability, for your data layer databases, whether they're in the rack systems or in your data guard systems. The focus being the database is always available. And always available for connections. So for users and applications to connect to. Okay, so we're building on top of that. We're raising the stakes, or raising the eye level, you might say, from the database up to the application level, the users. And what is the impact of any changes that might cause interruptions at the data layer on those users? And we're trying to hide what that might be. So if in many cases, we're just actually replaying interrupted transactions or connections and sessions behind the scenes, automatically, without you having to worry about it, without the application owners or the developers to have to worry about it. Whether it's for planned maintenance, which is very common these days, weekly, monthly, at least quarterly, there's at least applying RUs and so forth, as we highly recommend. But it also works for outages. And I mentioned data guard. So failovers, switchovers, this is all hidden as well, all incorporated, and requires no code changes for the application, assuming they're, of course, using best practices for application development. And even the cases where, well, you don't own the application, so you can't really change it. We still fit. And whether you're in the cloud or on premises, it's exactly the same. No changes, same configuration, regardless. And that's all it is. Configuration changes for the DBAs and for those people in charge of the applications and their deployment. So as I mentioned, MAA is the base. If you don't follow these best practices and so forth, some form of the blueprints, well, it's really difficult for us to provide high availability, you might say, or resiliency for the application if your data layer is not so highly available. If it's not there, applications don't work. So you got to make sure that's in place first. But on top of that, we provide draining and failover support within the rack system and across the data guard during role transitions. Okay, so what do we, this is a summary of what we've just been talking about. Key points being, we're going to provide coverage, protection for your application and its workloads during planned maintenance and outages, timeouts, whatever they might be, including networks. So for whatever application interruptions or interruptions to accessing the data that occur, what we're going to provide coverage for. So as again, we're building on top of high availability. Off on the left, this is what everybody thinks of as high availability. It is. The database, the data is always highly available. If you follow the best practices, you implement rack, use data guard for disaster recovery, you're always going to have data and it's always going to be available. The emphasis is there. But we're building on top of that, as I mentioned. We want to see what the users see. And instead of seeing, oops, we got an error because we've taken this instance down for maintenance, or the instance or the node in the cluster crashed. The other three are available, but this one crashed. Well, the users connected to it, they're interrupted. They're impacted. That's what we're trying to avoid. So your users do not see whatever is happening at the data layer. A key component to this we introduced in the time of 12.1, okay? And it was implemented as part of the Java standard. Now, Oracle owns Java. We bought Sun, and so we inherited Java. But we don't control it in its development. That's part of the Java Standards Council. And we took this idea, I'll explain it in a moment, to the Java Standards Council, and IBM were very supportive of it. And lo and behold, it became part of the standard in JDK 9. And we carried it through. We're strongly committed to its implementation. And what I'm talking about are request boundaries. And really, it's the request itself and how we delineate that unit of work with boundaries. In this example, we're seeing explicit request boundaries being provided by taking a connection from a connection pool, borrowing it, doing your request, processing the request, whatever that might be, SQL, PL/SQL, all sorts of calls, all making up a unit of work. And the application knows what that is, and it can define it. So borrowing the request or connection from the pool and returning it. Okay, so if you're using a connection or an Oracle pool, in this case, 12C or higher, then this is explicit boundaries we're implementing. Okay, so it's very simple. The database sees the beginning of the work and the end of the work, and it knows what those bound the request as a unit of work. And we use that in many cases, and I'll explain as we go through. Now, when 19C came along, or in fact 18, but primarily 19, we introduced transparent application continuity. And this is a slightly different configuration for application continuity in that it does not require connection pools. It works best with them, but it can work without them. So if you have legacy applications out there that do not use pools, or an application that you've currently developed or somebody has come off the shelf, but does not use an Oracle pool, then transparent application continuity can do the same for you as far as defining the requests. It's built into the database. Its ability to delineate where the connection or where the database request starts and ends. And it's all based on what it sees as state changes within the session. So a state change in this case might be, well, I'm opening cursors, or I'm committing, or closing cursors. Those are the most common scenarios. Or you're establishing NLS parameters and so forth as part of a log on trigger or something like that. Well, that suggests you're starting work and ending work, essentially, with those closing the cursors and committing. And that's what it infers from those, those are the request boundaries. Okay, so implicit request boundaries. And where do we use them? As I alluded to earlier, we're going to use them for draining, workload draining. That's for planned maintenance. Load balancing that goes on for all the time, whether we bring up and take down instances or nodes in the cluster or services. Okay, recovery and so forth. These requests are processed and used as that delineate or a unit of work throughout the database. And the use cases, as I mentioned, primarily are planned maintenance on the left. We can schedule, in-flight work gets drained and so forth. We can schedule it any time now. Now, planned maintenance typically, and this has been available for you since 10.2, was the concept of workload draining. And associated with that are the database services we also introduced in 10.2. And on the far right, we see unplanned outages, which is by far the most impactful. Well, I guess suddenly impactful scenario. Well, it's unlikely this is going to happen. But when it does, we want to make sure the application or the users do not see it. things happen. And we hide all this stuff from them. And essentially what is happening here is those in-flight requests and so forth, the database requests we were just talking about, are being processed by this node, and the node crashes. Then what we'll do is we'll automatically replay them elsewhere in the cluster and return the results to the users. So they won't even see it. And the same would basically occur if you're doing this failover or switchover to DataGuard. You do the roles transition, replay the work, and return the results. And incumbent with all this, how we manage planned maintenance and unplanned outages for various events, there's load balancing built in. It's automatic. It's always going to occur. And especially helpful when you're using a connection pool, right? Because that's one of the benefits of most connection pools, but especially with the Oracle's pools. Okay. So let's start talking quickly, very briefly, about unplanned outages. Essentially what is happening, as I mentioned earlier, we've got a user, application, whatever, submits a request to node 1 over here on the far left. Okay, it's being processed. But then there's an outage. We either lose the database instance or we lose the node. If it's just the node, then what will happen is it will automatically reconnect to another node in the cluster. In other words, remember we're using database services. And so the service will automatically start up on one of the preferred or available nodes. It may already be there, but all the same. We reconnect, to, in this case, to node 4, and we replay the request automatically for you. The application, the users, not doing anything here. It's automatic. The reconnection, the replay, and return of the results to the users, as if nothing's happened. The result being returned to the user or the application is to be exactly the same, processed exactly the same as it had originally been submitted. Will be no difference in terms of languages, decimal places, units, place and order of the return set. If you're returning a query, it's all going to come back exactly the same order. And that's the same if you have to do actually a failover to DataGuard. Now there would be some delay there, because you know failovers or switchovers, they're not instantaneous, not like when failovers within a rack system. So there'll be a brownout, but there will not be an interruption to the service being provided to the users. So in this case, instead of if the entire primary rack system died, we do an automatic failover to the DataGuard side, the secondary side, do the role transition. The user session would automatically connect, and the replay would take place then, return the results back to the users. All automatic, unseen by the users. So again, we want to make sure you're going to meet your SLAs and so forth. It's very straightforward. Within the rack system, it's a blip. Users won't see it. Obviously, there'll be the delay with the failovers to DataGuard. But everything has to be correct. And we will guarantee that any one of these transactions only commits once. And we're not going to get duplicates. Okay, so it all works very well. There are 2 configuration options here. I mean, the first one we talked about was application continuity. And that was the one we introduced with 12.1 for thin Java. And in 12.2, we added ODP.NET and OCI, okay? Required an Oracle connection pool, whether that was the Universal Connection Pool, UCP, or the OCI session pool. In every case, it has to use a pool, an Oracle pool. Now, that's fine, because UCP can be substituted for many or most third-party connection pools under your specific application development framework. So if you're using Spring or using IBM's WebSphere or even JBoss, we can slide UCP underneath in place of the default connection pool, and you're fine. Minor configuration changes, that's all is required. Now, application continuity, the basic configuration, was nice in that it could work with all these pools, okay? And it's to some degree customizable. So its behavior and how it replays or what it replays. Okay. So, very good that way. But we introduced transparent application continuity with 19, as I mentioned earlier, to deal with applications that do not fit this mold. And that would mean all your legacy applications. And Oracle has some of those too, right? We got eBusiness Suite and JD Edwards, Siebel, PeopleSoft, and so forth. Okay, they do not use pools. So we wanted to be able to expand or broaden the pool, you might say, of applications that we provide protection for. And by incorporating the capability to delineate database requests from within the database. So the database sees this stream of requests or calls coming from a user session, within a user session, and can figure out where the database request starts and ends. So it can manage that unit of work, okay, accordingly. Okay. Now the thing is, I mean, we designed transparent application continuities configuration as the, like the default, okay? Put it in there and just let it rip. You don't have to manage it. We don't care what the application's doing because it's always going to work. And that's what we've actually turned it on in our cloud. So you can use it by default if you wish, assuming you make those configuration changes in your application to recognize it. That was very minimal, okay? And what the implication there is that we have to be somewhat conservative, or let's put it more mildly, very conservative with this because it's turned on by default. Everyone's depending on it. So we need to know exactly what it's going to do no matter what. And it's not going to we can't customize it based on whatever. That means decisions are made for you rather than you being able to make the decisions as far as replays and so forth. So while the original AC configuration was a bit more limiting because you have to use an Oracle pool, at least it was somewhat composite. It is customizable. Okay, and we'll get to that in a moment. I'll explain in what ways they are. I'm going to do a quick demo here. I'm going to run through it very quickly. And this is actually the 12.2 demo. It's basically going to show you the very graphically, it's simple, of what is the difference between a normal connection to a database service, top one, and the bottom one. Now the top one's going to have the fast connection failovers as mentioned, so it's automatically going to, as soon as it sees a problem show up in the connection, it'll automatically reconnect elsewhere. The bottom one has that plus application continuity configured. Okay, so we're running two parallel streams of swing bench. They're doing exactly the same. Okay, we're balancing the load across 4 different nodes in the cluster. So be it. Okay, now that's fine. So we've got some semblance of balance. Now we're going to inject a failure by killing a PMON. Okay, and here you can see what has happened. The failure has been injected in both systems. The top one, you can see all the error messages coming back to the application or the user. And the user or the application has to deal with that. Okay, now they're gonna, with SCF, they're automatically gonna reconnect to another node in the cluster quickly. That's fine, but you've got to deal with all the errors. Are you gonna resubmit them? Do you have to type it all in again? Or somebody built that resubmission into your application. That's up to you, but it's an awful lot to handle, okay? The bottom, as where application continuity is doing this, it's automatically doing all that for you. And you can see no error messages coming back to the users. I mean, it sounds like it's totally manufactured, but this is exactly how it behaves. Okay. Very simple. Okay. Now, we've done unplanned But what about planned? And this is the one that actually it impacts the people most, because it's happening all the time. And in many cases, you're planning scheduled outages or planning outages for maintenance, which is silly. You don't have to do that. And you shouldn't have had to do this actually since 10.2, but a lot of people just aren't really aware of the benefits of database services and workload draining and not taking advantage of it. Now, that being said, workload draining will take you so far, but there's a gap, and I'll explain that in a moment, in which application continuity further enhances that capability, like to drain the work for planned maintenance, planned events. Whether it's maintenance or not, you could just be planning something, I don't know. Anyway, so let's just talk about the way it works. And I'll be very, very brief on this one. It's easy enough for you to read. We connect to a database service on node 1. Now, the DBA, I presume, funnily enough, the bulk of my audience is generally DBAs. The first step here is the DBA wants, or somebody wants to do some maintenance on that first node. And so what they do is they relocate or stop the service. The service is running on node 1, so they're going to move it elsewhere. So there's an SRVCTL, relocate or stop that service. And in fact, they're relocating it to node 4. Okay, so he automatically starts on node 4 before it stops working on node 1. So at some point, we start up the service on node 4 to receive new connections, new database requests, and the one on node 1 goes down. So it stops receiving database requests. At that point, then we start draining the work from node 1. This is what we're talking about, draining the work, or completing the in-flight request, database requests and sessions from node 1 all the way through. The database marks them all to be drained. It drains them, completes the work. At the end of the drain timeout, it returns, it makes sure all, as each of those, as each of those database requests and sessions drain, they're returned to the pool for reuse. And the results come back to the users, right? So at that point, where all the new requests are going to node 2, and we finish draining the work from node 1, we can take the node or instance down for maintenance without impacting the users. Note that the first work that the users submitted has finished draining, and they return the results back to them. And anything new they've submitted has gone to node 4. So at no point in time are they lacking service. In other words, there's continuity of service for them, but we've taken node 1 out of the mix so we can do some maintenance on it. We do the maintenance, bring it back up. We automatically load balance back. So we're using node 1 again, and we do the same thing on node 2, followed by 3 and then 4 with rolling patches or whatever that might be. Okay, very simple. Okay, invisible to the application and users. So as an explanation, let me just show you this a bit more detail. Well, more simply. 2-node cluster. We got a workload on node 1 and a workload on node 2. For some reason, it's exactly flat, constant. At some point, we want to initiate that draining prior to doing the maintenance. And so the DBA would, at point 1 there, would start draining by issuing the SRVCTL command. It's either SRVCTL relocate service or stop service. Use the relocate when it's singleton. If the service is defined as a singleton, it runs only on one node at a time, or limited nodes, then you would relocate it from one preferred node to another or available node. If it's a stop, well, that's when you've got a uniform distribution. If you got that service is running on every node in the cluster, you'd stop it because there's no need to relocate it. The service is already available elsewhere. Okay, so we start draining. Now what that means is, of course, the in-flight requests are draining, or the work is completing from those in-flight requests for node 1. No new work is going there. It just means we're completing the work. And as the work is completed, the connections are returned to the pool for reuse. And the new requests are being redirected to where the service, or directed to where the service is now running and available, which is on node 2. And you can see the workload for node 2 increasing. At some point, the drain timeout, whatever that period of time is, ends. Now, we generally, if you're talking about failovers or within a rack system, there's no reason to be parsimonious, you might say, with the drain timeout. Better to use a longer one. Now, you can see why. Because if your in-flight requests drain fine within that drain timeout, that's great, right? But what about those outliers? Or those long-running queries that you had no idea was going to be that way? What's going to happen to them? Well, they get cut off at the end of the drain timeout. So if the longer it gets, you can make that drain timeout because there's no time pressure here. Remember, your other connections in database or new connections to database requests are being processed anyway. So let's just let that drain timeout go as long as necessary. But all the same, it ends. And at that point, anything still outstanding that has not finished draining by the end of the drain timeout is cut off. That's what you've got today. Okay? That's how it is. You get errors unless you implement application continuity. And this is where AC or application continuity enhances this draining or this planned maintenance. Because those in-flight requests, instead of returning errors, now get replayed automatically on node 2 in this case. And the results return to the users as if nothing's happened. They will not see even a blip in performance. It'll just come back so quickly, who cares? Okay? And we see this time and again on very, very busy systems and quiet systems. The performance, there's virtually no impact to it on an ongoing basis, and response time to database requests is not impacted. Okay. You can say, how's that possible? Well, remember the most database requests, especially an OLTP environment, come and go so quickly that the actual unit of work, the database request, is quite short. And so reprocessing, you might say, is going to be quick as well. Okay. I'm going to show you, this duck gets me every time. It's going backwards. Okay, so here's another demo, and actually this is a very good one because it shows you what's going to happen kind of highlights draining and application continuity all at the same time. Real bonus. So let me just set the stage a bit here as we're trying to show with some of these arrows. We're going to see two windows here of significance. This one off to the left that the arrow is pointing at is going to show you in real time, well, kind of, this is a demo after all, of the application continuity. Okay, it'll highlight that. And I'll show you exactly what I'm talking about in a moment. And on the far right, on the other window on the top, that's going to show you the draining. Okay, so we're going to do a planned maintenance event, and you're going to see the impacts of it. Okay, let's carry on here. Okay, so we've got a user connects that we hear to and does an update on his my orders table. Okay, and then he goes for lunch. Okay, so while that's processing, that's great. We're going to submit a workload through Swingbench to show draining, right? Because we need some sort of workload. And now what we've got here is to show you this is the first user. He's on instance 2. That's significant, okay? So he's done his update command on my orders table on instance 2. Now we've come along to the Swingbench, and we're using this connect string. The reason why we're highlighting that is because that's significant as far as the functioning of receiving fan events, and which is key, along with database services, to make this all work. So now we've got 41 sessions running on instance 2. Okay, and that's what we're trying to highlight over here on the top left, showing you the, but you can see now we're going to stop or relocate the service. This is the SRVCTL command I was referring to earlier. He's going to relocate the service, okay? And in this case, we set the drain timeout as 10 seconds. You see the 10 over here on the top left? Well, that's awfully short, but we're only saying it that short for the demo. Typically, you know, you're going to see 60 seconds or longer, even for OLTP. Okay. And again, no reason to be cheap on this. Go make it longer than necessary, just to be on the safe side, to collect all those errant or unexpected database requests, longer ones. Okay. And of course, your database, your timeout there, I hate to harp on this one, but really is a matter of, it's working on the service. And each service is created for different workloads. And that would be typified by different drain timeouts. So if you've got an OLTP service, or a service that is meant to be supporting OLTP workloads, your drain timeout is going to be short, 60 seconds. There's plenty of time, right? Even for outliers. But some cases you can go up to 5 minutes, 10 minutes, doesn't matter. If you've got on the other hand, if you've got a workload, a short running batch or something like that, or queries only, you know, that's going to have longer database requests, longer running ones, not necessarily more calls, but potentially longer queries or longer, they just process longer. Then your drain time probably should be longer for that particular service. Okay, so you probably want to create services particular to your workload. An OLTP one for sure, because that's really the best fit here. You might want something for a mid-sized batch. If you've got another one for a long-running batch, that's fine too, okay? So it allows you to set a drain timeout according to that workload. Okay, so now on the far left, or right now, you can see what has happened. We started draining instance 2 because that's part of the relocate service, right? And it went down from 41 to 15 very quickly, within 10 seconds. Okay, it had to process, it was done. Okay, and again, that's just for the demo. And you notice now we were on instance 1, and you can see the workload picking up on instance 1 as there's 16, it'll be up to 41 soon enough, as the swing bench client connections are processed and handled now on instance 1. Okay, so we had 41 on instance 2. We did the relocate service, we drained them, and reestablished new sessions on instance 1. And you can see the buildup as the new connection requests are processed. Now we're going to come back to Joel Blow over here, who went for lunch. And now he had a quick lunch, 10 seconds, was it? And he's going to come back and realize he'd not finished his work. What a moron, right? You know, so now he's going to do a commit. Now, it's pretty obvious, right? He did the update on instance 2. Same connection, hasn't shifted. But the commit was actually done on instance 1. So started the database request on instance 2, completed it on instance 1. No errors. So I'm just going to confirm that. If we can type. I think we get this right for a recorded demo. Okay, so he's in instance 1. Okay, so pretty straightforward, nice and simple. The draining on the right, we established the 41 connections being processed on a continuous basis. We gradually shifted they drain and reestablished themselves on instance 2, or instance 1, I should say. And the update started on instance 2, completed on instance 1 without errors because application continuity replayed it. Okay. Nice and simple. Okay. So where are we here on the roadmap? You've seen how maintenance can be scheduled anytime. And that's principally the big draw here, funnily enough. We originally designed this for unplanned outages, but we're finding planned maintenance is the real driver because it's happening all the time and interrupts people all the time. So if we can manage that so that you can have planned maintenance in the middle of the day, anytime you like, you're not scheduling it anymore. You're just doing it. You're not doing it at 3 o'clock in the morning on a Sunday anymore. Forget it. So P12C, what was available? Well, we couldn't handle unplanned outages, not very well, okay? We introduced FAN, but really came into in 10.2, okay? FAN and database services all came in at once in 10.2. And in 12.1, we introduced application continuity and the capability to auto-configure FAN. Now, what does that mean? Well, we're actually auto-configuring the ONS endpoints, okay? So if you use that connection string that I was referring to in that demo, and it's in our technical briefs about this, you can get those from the application continuity homepage, product homepage. We auto-configured FAN for you, okay, the endpoints, so that your application, your connection pool will receive the FAN events and know what to do with them, okay? In other words, fail over the connection elsewhere, FCF and so forth, okay? And then we added drain timeouts and stop options and group management of the drain events or the initiation in 12.2. We also introduced application continuity coverage for ODP.NET and OCI. Okay. And then we went into various other pieces. And transparent application continuity, or TAC, was first introduced actually for Java thin drivers in 18C, but really matured for 19. So if you're hoping to do this on 18, yeah, I would stick with the AC configuration, the basic one with the pools. Otherwise, go to 19C as quickly as you can and use TAC there, or AC. They both have a place, and we're still going to support both of them. Okay? And you know, if you want to know more about when to use one or the other, talk to me after the fact. I'm going to talk a bit more about these ones here, these new features coming. In fact, in many cases, backported to 19. First of all, is planned failover. It sounds like we're planning to fail, but in fact, what it is, I was talking about draining database requests, and what happens when the drain timeout ends, or whatever you might say, and then we just have to cut them off and then go and replay them. Well, if the database knows or is pretty sure that those requests or particular requests are not going to drain fully, then why bother draining them at all? We'll just move them over and automatically replay them from as soon as they get marked. So as soon as the database knows it's supposed to be draining, it'll mark all the sessions to drain, and including, you know, look at all the database requests. But it knows statistically that this one or these other ones are not going to drain. It's very unlikely. So I'm just going to fail them over right now and carry on. Faster, simpler, and predictable, shorter maintenance windows, at least for the draining, okay? And again, if you've got database requests that come out of the norm on this particular service, you normally can drain them all within 10 seconds or 30 seconds or whatever it might be, but we've got one that's going to go 3 minutes. Well, it's a way to handle that. It's going to automatically get failover right away. Okay. The next one, this is a little disturbing for most people if you don't realize what is happening. If you're using a connection pool and a user connects to that pool and establishes their session, they create temp tables one way or another. They open cursors for fetch, set up PL SQL globals. That's great. They process everything. The database request is submitted. Everything comes back and nice and green, everything else. Then they return the connection to the pool. Done. The next user comes along, gets that same connection. Remember, it's connection pools. They're shared connections, reused connections. In which case, they inherit the state of that session that was left by the previous user. temp tables, cursors, and so forth. Now, they may not see them or know that they're there, but they actually are, and they could stumble on them, or at least they will still be taking up resources within the connection. And so what we've provided for the DBAs, at least, is a way to reset that state automatically when a connection is returned to the pool. And we provide that by an attribute on the service called reset state. So if you enable it, it will the database itself will automatically clean up the session state for connections returned to the pool or shared connections. Okay. Lastly, we've got a new version of ACCHK. Now, most of you probably aren't aware that ACCHK was a utility, or basically as an option under ACCHK. And that ACCHK option allowed you to verify whether your application was going to, and calls within your application were going to replay or not, because there are details under which, or situations under which certain calls will not be replayed. You got to think of application continuity as the insurance policy for your application. That's the best analogy. It's going to be providing a level of protection that you should become comfortable with. But there's fine print, as there is on every insurance policy. There are going to be exceptions to coverage. And this is one way to find out what that's going to be. Okay, there are going to be certain calls, and I can discuss, I'll give you a few examples, that will not be replayed. Okay. And in this case, what happens is with the new version of ACCHK, this just runs as an external utility and runs in the cloud or on premises exactly the same. And that's what the features of the new version of ACCHK. And it gives you more details about the calls and what calls will not be replayed. The way it works is it generates trace files, exactly the same as you might see from TK-Prof, say, if you're doing performance analysis and so forth. But ACCHK captures the trace files of your workload. Now, you probably want to do this with a short, broad test of much of your application as you can, okay? Just to make sure you get full coverage or evaluate full coverage, but not too long, because otherwise the trace files become enormous. But that's okay. It's enable, disable, and this will disable automatically, so it isn't ongoing. So you can just enable it, and a minute or two later, it'll disable automatically for you. It captures the trace files and then builds tables on top, or views on top of those trace files within the database. So you can query them much as you would do all other DBA tables, okay? Now, we also provide the capability to generate some reports, okay? So in this case, in the example shown, if you can see in the, we generated the full report, summary report, okay? And you can also generate detail reports as well, okay? In this case, you can see we disabled on a call with a SQL ID of this awful string. We all know SQL IDs are awful. But as an execution, a commit, and so forth, these are disabled for whatever reason. Okay. And there's all sorts of examples of that. We will not process or replay XA two-phase commit transactions. They're managed outside the database. If you're running transparent application continuity configuration, which is the case here, we will not replay side effects. Side effects are external calls from within the database. So util file, util underscore email or mail. Okay, so if you're trying to send an email from within the database, we won't send it again for you. We will not write records into an external file twice, so you won't get duplicates. Now, you may wish to, in which case that's the customizable part of the application continuity configuration. Okay. So that's basically it. We have a lot more details out there, and you're very welcome to contact me directly. This is my email address. Or you can go to the product homepage at oracle.com, go to AC. AC is application continuity. Please let me know if you have further questions. And I think we're going to open it up for Q&A anyway, a live one, because I'm done. Thank you very much. Are there any questions in Q&A? It's the time to ask. There's a lot of details that I have not covered, and I'd be happy to discuss them if you have questions. No? Hey, this is great. I covered everything, all the details. Golden Gate, haha. Okay, so an interesting question from Nazir. One of the things I mentioned here briefly was exactly the same database, okay? And that's an absolute requirement. What I mean by that is it seems obvious to you. It's the same database, same data, we're good, right? Well, you think of DataGuard as a physical copy of the primary database. And that is basically the case, right? Because you're instantiating that via an RMAN backup or whatever it might be, and away you go. So the key there is it has exactly the same SCNs and exactly the same object IDs. It's a physical copy of the database. So we can support that because it's easy enough to find where the objects are and replay everything accordingly, including the cursor IDs. Okay. On the other hand, Golden Gate is a logical copy. It may start off as a physical copy, but over time it diverges in terms of SCN and object IDs, and it certainly does not have the cursor IDs that we and so on and so forth that we had originally associated with the primary. And so we cannot support that. We may be able to do in the future. We're looking at that, but right now we do not work with Golden Gate or other logical copies. Okay. Sequences, Gabrielle. Sequences are what we classify as mutables. Mutables are function calls within the database that return the different value every time. And sequences are the most common, or most easy to understand. Order next val. If you're returning next val, well, we guarantee you're going to keep that value. So if you queried, as part of your original query, you included a call to next val on a sequence, and you got 47. When we replay it, it's going to be exactly the same. We'll inject the 47 back into it. The same goes for sys_time, sys_date, and so forth. Where it does not apply, though, are things such as $instance. This is a common problem when people are testing this out. They do a query on $instance when they're connected to node 1, of course, or instance 1, and it comes back with 1, right? When they do the same query or trying to replay that same query on node 2, it's not going to be the same. And so it'll fail. We won't replay something that will return a different result. Okay? And we can't lie about $instance. Okay, so that applies for all those mutables and so forth, but there are scenarios where we do not replay. Another example of what we will not replay would be some of the DDL. If you've added a data file, we're not going to replay that. We're not going to give you another data file with exactly the same characteristics. For unplanned outages, this is from Amit, how the DR database gets switch over or become primary without disruption. Okay, so you're using the broker. You have to use the broker. fast start failover, and max availability mode. Max performance does not guarantee data loss. And we have to be able to depend on that data being available. Okay. So in this case, what we're talking about is when the broker initiates a switchover or the failover via the observer, then obviously the database requests on the primary have gone. I mean, they've disappeared. Okay, because the database is gone. So what happens is we do the role switch. What used to be the standby comes up as a primary. But in the meantime, your application has been trying to connect, right? And that's part of the connect string. And the bulk of those requests and the status of those requests is still within the cache and still trying to connect. And so when it connects, the database recognizes some outstanding requests, it replays them automatically and returns the results. Okay, so it's a matter of building the connect string correctly. The one we'd recommend, go to the product homepage, and it's in the white papers there we have, or the technical briefs. It'll show you exactly how it happens. But obviously, there's that switchover or failover period of time that's it has to happen. The role switch takes time, typically 2 minutes, which is out of the box, maybe a bit longer in some cases, but you can certainly tune that down. But typically you're starting off with 2.5 minutes, and that's sufficient. But of course, hopefully your application doesn't time out during that period of time, okay? And to some degree, you would probably have to tell your users, if you get in the hourglass for 2 minutes, just live with it. That's all they'll see. They'll see an hourglass. Okay, and then the results will come back to them. Active data guard, no. If you just want to do it on your rack system, fine. Now, the licensing for this is all free, right? It's part of the rack code or database code, in fact. What you need for licensing is either a rack license or an active data guard license, one or the other. Typically it's rack, because this is in support of availability for an application. Okay, so we didn't anticipate you want to have high availability for the data layer. Okay, restart like EBS when every connection gets disconnected. How to handle in case application requires. Okay, so yeah, it's funny here because EBS is changing in this regard. Okay, we're working very closely with EBS or eBusiness Suite, so they do not have to redo all this stuff. And this is not atypical in approaches for. In fact, many cases for app servers, it's the default behavior to automatically restart or reboot the connection pools when they get a connection failure. As part of our recommendations, when you start evaluating application continuities, we automatically switch this off. And this is one of those functions we're working with the eBusiness Suite team to consider. Okay, so the connection manager does not disconnect everything, okay, and does not require that reboot. Now, some cases, eBusiness Suite still requires it. In that case, there's not much we can do. If the application goes down, or you lose your pools all at once, for whatever reason, which is kind of bizarre, can't do much about that. Okay. Yes, so Timo, yeah, so TAC, if you drain and relocate services and so forth, events, what is happening there? If you've not got a connection pool, then how do you how do you tell the application that you're draining? Simple if you got the pool, because the pool recognizes that you're not going to be able to connect there anymore. It'll go somewhere else. But in the cases where you do not have a pool, it's a bit more difficult. And so what we require there is to enable connection tests from the application. Now, most applications frameworks have that capability already built in, okay? Or applications themselves, eBusiness Suite and so forth do, okay? So your legacy applications and have a capability to enable connection tests. And the way the connection tests work is each time the application wants to submit a new database request, it sends out a connection test to the database, asks, is it okay for me to connect via this service or this, and so on. And the database says yes. Okay, and off you go. If, on the other hand, it makes the application asks and the database is in the middle of draining on a particular instance and work or service, then it will say no. It'll deny the request connection test, and the application will connect elsewhere to wherever the service is running elsewhere, that is. Okay? So that's how it works that way. And so if you're using TAC and you're not using a connection pool, then you use connection tests. Oracle result cache, no. It's exactly, there's no change to that. Okay, we're going to see exactly the same as we would otherwise. Oh, Gabriel, another question about database. This is a funny topic, this one, about database services. Someone's somehow come under the misconception that a lot of database services are slow to start, process, and manage. And it's confusion with other factors that are going on at the database. And it isn't the services that are slow, or even the fact of starting up database services and so forth. That's not a problem. It's microseconds. So they do not queue up on control files or whatever, okay? So there's no NQs that are causing you problems as there might be for other resources within the database. So this is, we've been doing, because of this how common this question is, we've been doing a lot of evaluations lately to find out if that's really the case, and it's not. So you're not in any danger that way. The role change, yes. The services are, remember, the database service has to be defined with a role, either primary or standby. Okay. And if you define it as a primary, then it will be automatically started up as part of the role change and on your preferred node. Okay. Relocate 10 database services on the same time instead of, yes. That was the group operations I was referring to, Gabriel. If you've got 10 or 100 services on a database node or in a cluster, a node in the cluster, then you can relocate all of them at once with one command. Okay. And what is the group operations for the srvctl command for stop or relocate. Obviously, you're going to have to stop some and relocate others, so it's probably down to 2 commands, right? But and you can specify a drain timeout that is common for all of them, or rely on the defaults for each of those services. In which case, your drain timeout elapsed time is determined by the longest drain timeout of all the services that you're actually relocating or stopping. Okay. When an application doesn't use connection pools, doesn't reconnect. Then we get drained from the. I think we've basically answered this one, York. You use connection tests, and that will initiate the drain or allow things to drain. But I'm not entirely sure what we're getting at here. The application doesn't use a connection pool and doesn't reconnect. Now, the reconnect is only for new requests. So. Or the replay of that, and getting results from what is drained for you if necessary. So I'm not so sure what you're trying to get at. Maybe just ask again more detail. Database links. Okay, so what is a database link in this case doing? Is it sending out as part of your request, you send a database, some transaction across a database link or a query across a database link? Why wouldn't we support the query across the link? It's a query, right? So as long as we can satisfy that query, that's fine. What we do not support, though, is updates across the links and so forth. Kind of makes sense, right? because that's a two-phase commit, and it's a little tough to do to that as part of the replay. But queries across links, yes. Okay. If you're bringing back, we can just reprocess the query. Now, obviously, there's some caveats to that. One is if you're doing a calling an exval on a different database, that's a little tough. But we don't see that very commonly. Okay. So, Yorick, any more details in your question? I'm trying to understand the context here. But if we're not using connection pools, will it get drained from the instance? Yes. There is a simple answer. Yes. When an application, okay, still a bit of a puzzle. We're done, though I think we've gone over time. Thank you very much for joining, everybody, and I appreciate very much all the attention and the queries, because obviously the questions at the end, because obviously you were listening. And yes, 45 minutes does not allow me enough time to go into details on some of these things. So if you are interested in more details, I strongly recommend reading some of the technical briefs and so forth available on the product webpage, and then contacting me directly for further detailed questions. Okay,